Okay, for this lesson today, we're going to look at the vertical motion formula to help us analyze some word problems. And we're not going to do all pieces of the problem right now in this video. We're going to do some things to get set up for class, and then we'll discuss some more things in class. So please make sure you set up your notebook. And when you're ready to go, on here I've listed two formulas. And what I just want you to realize is that there are two different vertical motion formulas. We're going to only focus on the customary vertical motion formula, but I do want you to see that there is a different formula if we were using the metric system. It has the basic idea as the customary, but because we're talking about different units of measure, the formula is a little bit different. So let's talk about the variables in this formula and what they mean. First of all, we have h of t. H of t represents the final height of our object that we're talking about. And this is measured in feet. We also have t. Hopefully we realize that t stands for time, and it's going to be in seconds. The v stands for the initial vertical velocity. So think about if you're throwing a baseball. It's that initial force or velocity behind throwing that the baseball. When you bring your arm back, it's the force behind the throw. And then we have s. Sometimes you'll see different variables than s. I think you have an activity where you see the value of c for this, but it's all the same thing. Basically, this value right here is going to represent the starting height. Where are you when you throw that baseball? Or if you're diving off a cliff, where are you when how high is the cliff? Okay, so read the first problem to yourself. What I want us to look at with this problem is I just want to look at how to fill in the formula, and I want you to decide what the best method to solve it would be, and write it down. No right or wrong answer. There's lots of different ways we'll be able to solve it. Okay, so looking at this, it says we're from a height of 256 feet above a lake on a cliff, Michaela throws a rock with an initial vertical velocity of 32 feet per second. How long does it take to reach the lake below? So we're looking for the time, so we know t is going to be our variable in the problem. Our h of t, our final height, if we're looking for where it reaches the lake surface is going to be 0. The negative 16 is a constant, so I'm keeping it negative 16 t squared because we're looking for the time. Our v, or initial vertical velocity, is 32, so plus 32t. And where are we starting from? We're starting from 256 feet above the lake. So that's how I would fill in the formula. And so I want you to think about all the different methods we've learned about for solving quadratics and write down which method you would choose to solve this equation. And then tomorrow in class we will actually go through and solve these. Okay, looking at the next one. A roofer tosses a piece of roofing from a roof onto the ground 30 feet below with an initial downward velocity of 10 feet per second. How long does it take to hit the ground? So again, our h of t, our final height we're looking for is 0. We're still looking for the time, so negative 16t squared. Our v is 10 feet per second, so plus 10t. And then it says that the ground is 30 feet below, so that must mean that the roof is 30 feet higher. So we're starting at a height of 30 feet. Okay, so again, look at your equation. What method do you think for you would be the best and easiest to use to solve this? Okay, let's look at the next problem. this problem is a little bit different. If you read it to yourself, you'll notice that it doesn't give us an initial vertical velocity, and this should say dropped from, not. Okay. And the reason it doesn't give us initial vertical velocity is because this shingle is dropped. If we drop something, we don't have any force behind it, like as if we were throwing it or tossing it up. It just falls. It just drops and falls on its own. We don't plan for that to happen. So just to write a general equation, okay, because we have several questions on this one. So h of t represents our final height. We still have negative 16t squared. Our v, though, since we're dropping it and there isn't any, would just be 0. So we're not going to have, if I put 0t, that's still just 0. We're dropping it from a roof that's 100 feet above the ground, so plus 100. So for the first question, it says, what is the height of the shingle at 1 second? So what I want you to do is I want you to think about and write down, what are we going to do? Where are we going to plug 1 second into our equation? The next question says, when is the shingle at 50 feet? Now I know we can graph this and we can look at it in the calculator looking at the graph, but my question is, where would I plug in 50 feet to answer this question? And then the last question, when does the shingle hit the ground? So what would we plug into this equation to answer that question? And I also want you to think about and write down, what solving method would you use to answer these questions? Okay. We're not going to look at the last example. The last example is one that I put for the metric system, and I decided that we weren't going to do that. Okay. So please make sure your information is filled in and that you're ready to pick up and discuss the questions that I asked in class.